an application of the maximum flow problems in which we discuss the Ford-Fulkerson algorithm and its modification as Edmund-Karp algorithm. So in this video, we will discuss about the application of the minimum cut problem. So what the minimum cut problem says is that in a flow network or in any given network graph, an ST cut is a cut that requires the source and the sink to be in different subsets. So I think all you know about a cut in a graph. So a cut in a graph is a division which we will make in a graph so that graph is divided into more than one component. And in a network flow graph, an ST cut is a cut that requires the source and sink to be in a different cut, where S component will describe the component which will have the source, and the T component will be the component in which sink has been placed. And also it consists of all edges going from the source side to the sink side. So in the ST cut, the cut will be described by the source and the sink, and they will be in different subsets, and also it will consist of all the edges that will be going from the source side, that is the component which will contain the source, to the sink side, that is the component which will contain the sink. The capacity of an ST cut is defined as the sum of the capacity of each edge in the cut set. And what edges we are including? We are including all the edges that are going from the source side to the sink side. So to find the minimum cut find the minimum cut in a flow network, we will use the Ford-Fulkerson algorithm. So according to the Ford-Fulkerson algorithm, all we are supposed to do is just run our Ford-Fulkerson algorithm, run the Ford algorithm, and calculate the final residual graph. So the final residual graph will be made by calculating the maximum flow inside the flow network. And then after calculating the final residual graph, all we are supposed to do is just find the set of vertices that are reachable from the source. So all the vertices that will be reachable directly from the source will be belonging to the S component in which the source is present. And then what we will do is that all the edges which are not reachable vertex, all the edges which are non-reachable vertex from a reachable vertex are minimum cut edges. So what I'm trying to say is that all the edges which are from a reachable vertex. So what is a reachable vertex? A reachable vertex is a vertex that is reachable from the source. So all the edges which are from a reachable vertex to a non-reachable vertex. So what is a non-reachable vertex? A non-reachable vertex is a vertex that will be belonging to the sink component. So all edges which are from reachable vertex to a non-reachable vertex are inside the minimum cut edges. So we will print all such edges. So uh, how the min cut problem is solved by this Ford-Fulkerson algorithm is that we get the capacity of the minimum cut. So how we are getting the capacity of the minimum cut? The max flow min cut problem inside a flow network states that the amount of maximum flow is equal to the capacity of the minimum cut. So we are not going inside the proof of how the minimum cut value is equal to the maximum flow, but just we need to keep in our mind that according to the theorem of max flow min cut, the maximum flow inside a network graph is equal to the capacity of the minimum cut. So for calculating the minimum cut, all we have to do is just find the final residual graph and then get all the vertices that are reachable from the source and the rest of the vertices that are in and the all the vertices that are from a reachable vertex to a non-reachable vertex are our minimum cut edges. So I hope the logic for finding the minimum cut value inside a network graph is clear to you all. So thank you guys. See you next time.